Hello and welcome to Open Source CNC. Today we are going to mill a cutting board. I know it has nothing to do with the title of the video, and that is because I'm not going to actually mill a wooden cutting board. That is what you would expect when I say that. Instead, I'm going to take this already made cutting board made of plastic and I'm going to transform it into vacuum clamps. What are vacuum clamps? They are pieces of material that you fit to your CNC table, and then using a vacuum pump, you're going to hold the workpiece to the table very firm, very steady, and you will be able to mill it without having clamps, standard clamps interfering with the spindle, having to avoid them, and so on. Why did I choose this cutting board? Because it's the cheapest and readily available option without having to go somewhere far away and buy a really huge piece of plastic. This is available in any store, and it has the correct thickness. It has an 18mm thickness. It has enough room for me to make 2 or 3 vacuum clamps. It's the ideal piece of material for what I need. So first, the design step. I'm in FreeCAD 1.0.1, the latest available version for now. I'm in the Path Design Workbench. Let's first create a new body, and inside this body we are going to create a sketch. We need to select the plane that we are going to create a sketch. I'm going to use the XY plane because I'm going to draw a projection of the object that we are milling, and the top projection suits best for this kind of application for making such a clamp. Let's create a rounded rectangle. Starting from the origin, you can see the little X around my mouse. Click here and let's make it 180mm by 180mm. Let's give it a radius. Let me just zoom out so we can see what I'm doing. I need to set a radius for the corners. I'm going to use a radius of 10mm, just so they have a very nice look. The sketch is green, it is fully constrained, you can see here in the solver messages, so I can close the sketcher editor, and with the sketch selected, select the pan button. I will give it a height of 18mm, this is the actual height of the cutting board. And now I need to create a channel for the gasket and the 2 holes, one from the top and one from the side, which are going to be the port where the vacuum will be created from. So let's select the top face and create a new sketch so we can define the shape for the gasket's recess. In order to do that, let's first set a top view so we can see a top projection. And let's create another rounded rectangle. I'm going to make it 130mm by 130 with a corner radius of 6mm. Now we need to center it inside the piece of material, and in order to do that I'm going to set the distance for the corner point. So select it, press L, and I will give it a value of 25mm. And for the same point, press I for a vertical distance constraint, again 25mm. That is because the entire object is 180. Since this rectangle is 130, it leaves me 50mm divided in 2 on the left and on the right, and for the vertical at the top and at the bottom. Now let's create another line with an offset of 8mm because that is the width of my gasket. Double click on one of the lines, you can see highlighted in red the entire connected line, and let's select the offset tool. Go here and check add offset constraint, and let's give it a value of 8, press enter, and I have some redundant constraints. Let's go to constraint number 39, which is a parallel constraint. Remove it, and now everything is green, everything is okay. Close this window, and with a new sketch selected, click on the pocket button, and I will make the pocket 2mm deep, just enough to hold the gasket, but high enough in order for the gasket to stick outside of the pad. We still need to create 2 more things, one hole in the center here and one on the side. First, let's select this face, create a new sketch, and now let's create a circle with a radius of 15mm. This will be the port where the air out of this area will be drawn by the vacuum pump. Let's select the center, press L to set it horizontally to 90mm. This is the center. and press I to give it a value of 40 millimeters. This should be far enough from the gasket, but still as close as possible to the bottom, so the other hole won't have to be too deep. Close the sketch and create a new pocket. This time I'm going to make a pocket of 12 millimeters because this will leave enough material at the bottom, but I can connect it to the hole from the side. Now let's select this side, create a new sketch, and here do the same thing. Let's create a hole. Just give it a 9 millimeter diameter. I'm going to put a connector which is a 1/4 inch. I've measured it. It has 10 millimeters including the thread, so 9 millimeters should be okay in order to stay firm in place without risking to break the material. So let's give it a value of 9 millimeters. Now select the center. Press L for a horizontal distance, again 90 millimeters, and again select the center, press I, and I will give it a value of 9 millimeters, which is the center of this material. It is 18 millimeters thick, so 9 millimeters should be in the middle. Let's click on the close button, and now let's make a pocket which should reach this hole. This hole was at 40 millimeters, so a length of 40 should do it. That is all you need to do in order to have the vacuum clamp modeled. If you want, you can make additional channels on the center. You can then move the gasket if you have smaller pieces, but in my situation I think this is just enough. I don't need to make any more. Maybe I will use the leftover material to make another clamp which is going to be smaller. And here is just something really important that I forgot to tell you in the beginning of the video. Remember to check the workbench that you are in. Here you can find a list of all the workbenches. Make sure you are in the part design workbench. Otherwise, all the things that I did to get to this shape won't work. You won't find the buttons. You will have some problems. So if you are new to FreeCAD, remember, check the workbench that you are in. You will need to be in the part design workbench. Now that we have the clamp, the pad ready, we need to move to the CAM workbench to make the milling, but there is one thing that I forgot to do, which is make the holes for fitting this to the CNC table. I'm going to use screws, so let's select this face, create a new sketch, and let's make 4 circles. I will place them somehow random, close to where I want them to be, but I won't bother with that. Then select the 4 circles. Holding the control down will help you avoid losing the selection, and press the E key to make them all equal. Now I can select either one of them. I'm going to select the top left one. I always do that. And let's give it a diameter. For that, I can either go to the toolbar here and set a constraint diameter, or press K then O. All these letters here are the shortcuts. If you find 2 letters, it means you first have to press the K letter in this situation, then release it and quickly press the O key. Now let's set the constraint diameter. I will give it a diameter of 5.5 millimeters because I'm going to use 5 millimeter screws to hold it to the table. You can see that all the circles are now reduced to that size. Let's zoom in and select their centers. First the top 2 ones, and press H for a horizontal constraint. This means they will always be at the same level. Do the same for the bottom circles. Press H. And now I will do the same for the vertical. Select the first circle, the one that should be just below it. Press V for a vertical constraint. And do the same for the right side. Now all I need to do is to position the circles. Select the center, press I for a vertical distance constraint. Give it a value of 12.5 millimeters. Select again the center, press L for a horizontal distance constraint, 12.5 millimeters. And now I still need to set the distance on the horizontal and on the vertical. So select the bottom circle center, select this center, press I for a vertical distance constraint, and since I have 12.5 millimeters, it means 25 added for the 2 circles. And let's subtract that from 180. Here is a little trick you can use in FreeCAD when entering lengths. You can use formulas. You can just enter the formula here, click on the OK button, and it will set automatically the 155 millimeters distance. Let's do the same for the horizontal. press L this time so we can set a horizontal distance, 155 millimeters, press enter. And also this point will be perfectly determined because it has horizontal and vertical constraints related to the other circles. The entire sketch is constrained, close it, use the pocket button, and this time I'm not going to give it a length, instead I'm going to change the type from dimension to through all. Press on the OK button and now you can see it has these holes all through the material. Everything is ready, well, almost ready. I could make some bevels for these holes, but I'm not going to bother making them on the CNC. I'm going to make them using a power drill because they don't need to be that precise. I just want the screw head to go below the face of the material. I can do that easily by hand. And now that we really have the clamp ready, let's go to the CAM Workbench and create the G-code. First, we need to set up a job. A job is a group of operations, so let's click on the job button. You can see all the buttons here are disabled. Until we have a job set up, nothing will be available. So let's create a new job. Make sure the object that we have created is selected. Click on the OK button. And here the default behavior is kind of annoying. It uses extend models bounding box for the stock and has an extension of 1 millimeter on all the axes. I don't want that. I will modify them to 0 because I want this bounding box to be exactly the size of the material that I'm milling, so I can easily set the origin. I'm going to set the origin on top of the material, so I need to select this corner, which is kind of difficult, but in the end you will be able to do it. Click on set origin button and you can see now the origin is in this corner. Let's add a tool bit because whenever you're creating a job, you need to have the tool bits that you are going to use for the operations. Go to the Tools tab, click on the Add button, and here you will have a list of the tool bits that you have defined on your machine. If the tool bit that you are going to use is not in your list, here is a quick guide on how to add those tool bits. Go check it out, then get back to this section and we will continue by selecting the tool bit, the 5 mm end mill that I'm going to use today. Click on Open, and now let's give some speeds. Since I'm using PE plastic for the first time, I will use the values from when I milled acrylic. Hopefully nothing will go bad. So I'm going to use 2500 millimeters per minute, both horizontal and vertical, and the spindle speed of 11,000 RPM. Select the default tool, click on the Remove button. Now let's go to Output to set the post processor. In my case, it's GRBL because that is what my machine uses. If you use a different machine, of course, select the proper post processor. Let's also set a file name, and I will call it vacuum clamp.gcode. Click on the Save button. When everything is set in the job edit, click on the OK button again to close the job dialog, and now we can start creating the operations. The first thing that I'm going to mill is this channel. So select the face, the bottom face, and go to the pocket shape operation. Change the pattern to offset. Let's use a step over of 80%. This time I'm not going to check the min travel because when the cutter head will lift and move to another position, it has enough time to cool down, which is really important in milling plastics on the CNC. I will go to the depth tab because I want a step down much lower than what is default set. I'm going to use a step down of 2 millimeters. Click on the Apply button so I can see the G-code that is generated. You can see it here, and it's just doing one pass because the channel's depth is just 2 millimeters. So in this situation, setting the step down didn't really have an effect, but it's really useful to remember to change all those values. I can click on the OK button. So now that I have created this operation, let's take a look at what happens on the CNC. And because it's the first time that I'm milling this type of plastics, I'm going to export this job, mill the first part. So after milling this channel, I will get back to FreeCAD, and only after that I will generate all the other operations. So to export the job, select it from the tree, click on this button, Post Process. Here you will see the G-code. Click on the OK button, and again click on Save in order to generate the G-code file. Now let's go to Universal G-code Sender, open the file that FreeCAD has generated, so vacuum clamp.gcode, click on Open. and you can see it loaded in the 3D preview. Let's feed the material to the table using double-sided tape and then set the axis and run the program. Now that the pocket shape is ready, let's make the helix for the round holes. I will make one helix operation for this holes, then another one for this hole here, and in the end I will make the profile. Let's create a new helix operation. By default it should detect all the round holes. It didn't detect this one because it doesn't have a flat bottom. So we'll have to manually set it in another operation. Let's go to the depth tab and change the step down to 2 millimeters. And in the operation, I don't really need to change anything because if I click apply, you can see that it will be only one pass. So for now, all the default settings are okay. Let's click OK to create the operation. Let's disable the pocket shape. Let's make it inactive. And let's export the job and mill it on the CNC. Again, the same thing, export. Click on the OK button. Now click on save. It will ask me if I want to overwrite, and I want that because it's as easy as going back to Universal G Code Center, clicking somewhere in the G code, and it will reload the file. Let's run the program. Let's see what happens. As you were able to see, I had to stop the operation because after the first hole there were a lot of plastic pieces around the tool bit. Most probably in continuing this job would have resulted in a tool bit filled with plastic, which it would have started to melt, and I really don't want that. So let's change things a little bit. Let's disable this helix operation, and instead of a helix operation I'm going to use a pocket operation, and you will see for the next 3 holes why I do that. So let's create a new pocket operation. Let's go to base geometry and click on the import from the helix operation. So we have all these faces already selected. We need to remove the first one because we don't want to mill that again. It's already milled. Click on apply and you will see some small circles. Let's set the depth to 2 millimeters. Change the pattern to offset. And now let's click on the OK button. I have everything ready. Let's re-export the job. So again, click on the post-process button, click on OK, overwrite the file. Let's see what happens. So things went much better using this method, and that is because, let me just zoom in and explain a little bit. For each of these layers, it will end the cut. Basically, it will cut all the way around, and then the piece of plastic will be thrown away. After that, it will drop another 2 millimeters, cut another piece, and so on. This is why it wasn't such a huge build-up with this type of setting compared to the Helix. Now let's create the same operation for this hole. I will select it from the tree, click on the copy operation in the job button. Now let's disable the one that we have already milled. Double click on this one, go to base geometry, click on the clear button to remove all the geometry. Let's select the outer wall, don't select the bottom because it will make a pocket with this shape, which I don't want. If I select the vertical wall, the round wall, and click on the add button, you will see that everything is exactly as I want. And now let's disable this one and create the final operation, the cut of the entire shape. For that, click on the profile button. Let's go to the depth tab and change the step down to 2 millimeters. Click on apply to see what happens. Everything seems okay. And I will set the direction counterclockwise. It will move this way. So I will end up with a conventional cut. It will cut much smoother. I've noticed it on the pocket. So let's take advantage of those observations and let's set the direction counterclockwise. Click on the apply button. Now I can close the profile dialog, select the job, click on post process, and this is the last time I'm going to do this. Click on OK, export it, and now go back to the machine and mill the outline of the object. In a normal situation, I would enable all these operations one after the other, well, except the Helix, which I don't like. So let's delete the Helix. And imagining that I'm going to do another one, let's add the first hole too for the pocket. So zoom in, select the wall, click on add. And now it will also mill this one. Let's enable all of the operations. And now if I export the job, I will have a file with all of these operations running one after the other without any stop, which is a normal way of doing things. But as I have told you, this is the first time I'm milling this type of material. It was a new thing for me too. So I wanted to do this together with you. I wanted to show you how I do things when I'm not sure about how should I mill a certain material, what settings, what feed speed, what spindle speed, and what type of operations to use. Now let's see the final cut and then we will test the clamp. And even though I said I would make this vertical hole using the CNC, I've decided that it's much easier using a drill. I would try to be as precise as possible. I can already see a problem. I drilled it very close to this area. Hopefully it won't get damaged when I insert this connector. And I will use this ratchet key to try to fit it here. And I really hope that this will be airtight. I should have drilled a slightly bigger hole because I can see here that little bump. So the pump works okay now. Now let's try a piece of real material. I'm going to use this MDF board, which as you can see was the first attempt at making such a clamp. It doesn't work because MDF is not airtight. It allows air to pass through it. But let's see how it holds down. I will press it a little bit and turn on the pump. And now let's try a different piece of material. So we have some leaks. Yes. So I've connected the pump, I've changed the gasket. Now it should hold, or hopefully it will hold. Let's place this piece of material here. Open the valve and turn on the pump. And everything looks incredibly sturdy. I will shut down the valve, turn off the pump. It will hold the piece in place for almost 3 to 4 minutes. I think it's good enough. The fact that it can hold this down for such a long time means that everything is almost perfectly airtight. The new gasket works great, so I don't need to change anything anymore. I have this piece of particle board. The clamp won't have any issue. Even after closing the pump, it still holds incredibly strong. I cannot move it, I cannot lift it. So this is what I would recommend if you wanted to do such a clamp: a good vacuum pump, a good gasket, some PhD material, and the file that you can find on my Patreon page if you want to download it for free. Of course, if you want to support me, it would mean a lot to me. So thank you to everybody who's supporting me through my Patreon page. And I will see you next time for the next project, which we will be milling using this clamp.